Hi, today we're looking at section 7-1, integer exponents. So remember to take out something to take notes on. Pause the video at any time to write your notes or to go back and review a concept again, and complete the check it out problems on your worksheet after each of the examples. Our learning targets: I can evaluate expressions containing 0 and integer exponents, and I can simplify expressions containing 0 and integer exponents. Remember, an integer are positive and negative whole numbers. So an integer, a 0 exponent, is any non-zero number raised to the 0 power, and that will always equal 1. So an example, 3 to the 0 equals 1, 123 to the 0 power equals 1, negative 16 to the 0 power is 1, and 3/7 raised to the 0 power is also 1. So any non-zero whole number raised to the 0 power. So algebraically speaking, if x does not equal 0, then x to the 0 power is 1. Our non-negative exponents is a non-zero number. Again, these both have to be non-zero numbers. Raised to a negative exponent is equal to 1 divided by that number, raised to the opposite, or the positive exponent. Whole lot of words there. All that means, if we have 3 to the negative 2, that's the same as putting 1 over it, 1 over 3 squared, which simplifies to 1 over 9. We do 3 times 3 is 9, 3 squared is 9. 2 to the negative 4th power is 1 over 2 to the 4th, which is the same as 1 to the 16th. Notice when we simplify, we work out the exponents. And we all have positive exponents, and then we can work those out. Algebraically, if x does not equal 0 and n is an integer, so then n, or x to the negative n will equal 1 over x to the n. So your exponents go from negative to positive, but they also change location. So again, just to review, remember that 3 squared, we have to simplify. 3 is a factor, and it's multiplied by itself twice. So 3 squared is 3 times 3, which is 9. So completing this table, if we had 5 to the 5th, that's the same as 3,125. That would be simplified. We have no exponents. We've worked it out. 5 to the 4th is 625. 5 cubed, 125. 5 squared is 25. 5 to the 1st is 5. 5 to the 0, we have a non-zero number raised to the 0 power, is 1. 5 to the negative 1 is 1 over 5 to the 1st, or 1 over 5. And 5 to the negative 2 is 1 over 5 squared, or 1 over 25. So you notice as the exponents go smaller, we went from 5, 4, 3, 2, 1. Our value is smaller until we get to negative exponents, 5 to the negative 1, and we end up with a fraction, 5 to the negative 2, and so on and so forth. So just keep in mind the base is a factor that you can be multiplying, and the exponent tells you how many times multiply the base by itself. So in this one, we want to simplify. To simplify means we have no negative exponents. So we have 2 to the negative 4th. That's going to equal 1 over 2 to the 4th. So when you're simplifying, draw in your fraction bar. And we get 1, and then 2 to the 4th goes in the denominator. And 2 to the 4th is 2 times 2 is 4, times 2 is 8, times 2 is 16. So it simplifies to 1 over 16. And here's your check it out to do. So again, to simplify means remove the negative exponents, make them positive, and see what you come up with. So now we're going to, or asked to simplify, again, means remove our negative exponents. This is going to be the same as 1 over 4 cubed, which is 1 over 4 times 4 is 16, times 4 is 64. 7 to the 0 power is going to be 1, non-negative number raised to the 0 power is always 1. Negative 5 to the negative 4th power is going to be 1 over, and put parentheses, negative 5, because everything here is grouped, to the 4th power, which is going to be 1 over 5 times 5 is 25, times 5 is 125, so 625. And again, notice the number went from the numerator into the denominator, and our exponents became positive. For this one, our negative sign's out front, so that stays. So we get negative 1 over 5 to the 4th, which becomes negative 1 over 625. It's really important to watch where your negative signs. Here are negatives grouped, and here the negative 4 is just attached to the 5, not to the negative sign. Here's your check it out. When you're doing these, simplifying, draw in your fraction bar and then move your numbers around. So we know it's going to be 1 over 10 to the 4th, and so you can go from there, figure that one out. Now we're going to evaluate expressions given a variable. So here we have x to the negative 2, and we're told x equals 4. So we're going to get 4 to the negative 2, which is going to become 1 over 4 squared, which is 1 over 16. For our second one, we have, right away we know, we have, let's write it out, negative 2 times 5 to the 0 times b, which is negative 3 to the negative 4. So simplifying, we draw our fraction bar out, we get negative 2, 5 to the 0 becomes 1. Negative 3 to the negative 4, this term moves into the denominator, and it's raised to the 4th power. So we're going to get negative 2 over 3 times 3 times 3 times 3, which would be 81. And that is simplified. We have no negative exponents, and we have no zero exponents. So here's your check it out. Again, when you have a non-zero number raised to the 0 power, it's going to become 1. So 6 to the 0 power goes to 1. And you can continue to simplify. So if we have an expression of the negative exponent in the denominator, such as 1 over x to the negative n, again, we would draw our fraction bar out, and that's going to go up to the numerator. So an expression that contains negative or 0 exponents is not considered to be simplified. We have to rewrite them with only positive exponents, which would be non-zero exponents. So here we want to simplify. We have negative exponents here, we have a 0 exponent. So again, when you start these, draw a fraction bar, numerator up here, denominator here. Take each individual term. Let's take 7, take that factor. 7 stays in the numerator. Now we're looking at w to the negative 4. That's a negative exponent, so w goes to the denominator, and our exponent becomes positive, and we've simplified. For b, draw our fraction bar. Negative 5, that's just our constant, so that factor stays in the numerator. But now k to the negative 2 is our denominator, so it's got to come up in the numerator and become positive. So that's going to simplify to negative 5k squared. And for c, again, draw our fraction bar out. A to the 0 becomes 1, so we get 1. B to the negative 2 goes on the bottom in the denominator and becomes b squared. Now our denominator, we look, so b comes down here, c's going up, so c is going to become c cubed on top, and d to the 6 just stays in the denominator. So simplifying, we get c cubed over b squared, d to the 6. So you only move the factors that have a negative or a 0 or a negative exponent. Here are your 3 check it outs. Again, always draw a fraction bar to distinguish between your numerator and denominator, and move your factors accordingly. So to summarize, as we stated, an expression is not simplified if you have a negative or 0 exponents. So you want to draw out your fraction bar, and if it's negative in here, it's going to move down to the denominator, or if it's negative, the denominator is going to move up into the numerator. And to simplify expressions with the negative exponents, make the exponent positive, and you move the factor to the other side of the fraction bar. Again, so up or down, depending on where it's at. So it changes location. So good luck, and bring any questions you have to class. Thanks.